Alrighty, hello, my darling dears, and welcome back to another beautiful day in the Science Center. Today, we're taking a look at number 34, which is Unit 3.2 with the nature of motion. We have already started this unit off with a bang with starting to talk about our pendulums and our carnival rides, and we are going to be diving back into that this week as well. But let's take a look at what you are expected to do on this assignment. So, when you open it up in Google Classroom, you will see your little instructions right there by your nice little roller coaster that it says for you to open up the slides, which the slides are right here, and then complete the notes either digitally or on paper. So if you want to do them digitally, then you can open this up and it brings up your interactive slides that you can actually input your answers there. Or if you prefer to do this on paper, then you can just go and pick one up from the front desk and you can put your name on it, and then you will be turning this in on paper with a picture that you are going to insert. All right, it says when you've completed it, you are going to turn it in and then give me a private comment telling me that you have done it either paper or digitally. So all you would have to do is just put a P or a D in there for paper or digital. Okie dokie. Now let's skinny over and actually start talking about this content. Okay, so in the previous section, we started learning about motion and how it likes to stay in a perpetual state. So that is like where our carnival ride, whether it be the dragon or the Viking ship or even the crazy shuttle that I almost died on that one time when I was 10. We are going to be talking about something that is wanting to stay in motion, and you can equate it to if you are in a car you are driving 65 miles an hour, then your body is going to be staying at that 65 miles an hour. Alrighty, so now we are kind of leaping off from that point and talking about the conservation of energy. And it may sound interesting slash kind of weird that we are talking about energy and motion at the same time, but remember back when we were talking about potential and kinetic energy. So everything in the entire world has potential for energy to be happening, whether it be light, whether it be heat, whether it be actual mechanical energy. Everything has that potential. And then when we actually enact some kind of force on it, then that's when it turns into the kinetic energy where it's actually doing something. All right. So apparently, we just really love talking about carnivals here and other rides of some sort. But on this slide, we're talking about the law of conservation of energy, that we cannot create energy and we cannot destroy energy. Very similar to matter. You can't just poof and make something appear out of absolutely nowhere unless we're in Harry Potter world, but that's not real. So, same thing with energy. We can't just like spontaneously poof and have energy out of nowhere. We can also say the same for we can't just make it poof and go away. All right. So these forms are going to be a myriad of different things. And what I really like about this is that just like everything else and pretty much every science class, it goes along with what the name is. All right, so we've got the radiant right there, which is exactly what it sounds like. It is going to be some kind of radiation of light, which is why it says solar energy or light energy. Then we have thermal, exactly what it sounds like, y'all, that it is going to be some form of heat. Now, that heat could come in several different formats, whether it be, from the sun or an actual like heat source like this right here with a fire that maybe we're building some s'mores in, but it's going to be some kind of heat. All right, now right here, we've got electrical, sound, and nuclear. So electrical is going to be like you taking and plugging in something to the wall or into some kind of outlet when you're trying to plug in your phones and charge them, or your Chromebooks and charge them. So that is going to require energy. And then that energy will then have to be cut off by you stopping that circuit and unplugging. We have sound. So when you guys have your little earbuds in and you are listening to whatever it is that you guys listen to these days, then that is going to be sound energy. And then nuclear energy, this is going to be we actually have a power plant in Dothan that does nuclear energy, but the actual definition of nuclear is exactly what it sounds like. It's coming from the nucleus of an atom. And that can come in several different formats, and it's not necessarily always going to be referring to a nuclear power plant, but that is a very good example. And then on this one, we were talking about electromagnetic. This could be anything that is going to be putting off a signal, whether it be an old school, radio tower that you are going to be listening to a radio station, or the actual radio devices in your phone. All right, so now we can talk about how those transfers of energy are going to be taking place. So you may have one form of energy that is then going to transfer into another form of energy. All right, so right here, we have the example of fireworks. So it started out as a, tiny baby firework that is just waiting there. It has the potential. It has different chemicals and things that have been put into it to take off and then radiate a specific color. And you're also going to have heat, you're going to have light, you're going to have all kinds of things enacting there. So it's going to start out as that chemical energy and everything that they have put in that canister for that firework. And then when it goes, then it's going to change into the heat and the light and the sound and all of those other good things. So once again, going back to, the law of conservation, like you cannot create it and you cannot destroy it. It just transferred. All right. So the exact same thing there with our solar panels. If you've never seen one of these solar farms, I highly suggest you to take and Google search it because these things are really rad, y'all. So you have a bunch of solar panels, albeit very expensive, and they have different mechanisms in them that are going to be collecting that energy. And then they are going to take that energy and pipe it through lines, and it is going to change into electrical energy. And any of those forms of energy that you may have studied before in another science class that are considered to be, quote, renewable energy, all of them are going to be working by this same exact mechanisms, that you're going to have something that is going to be working to spark a generator, and then the generator is going to make that electrical energy. So right here, this is where you are about to have to prove to me that you actually are understanding what we were talking about. So with this one and another one of the slides right after this one, you are going to have a quiz that is going to be referencing these different types of energy transfer. It already gives you the answer, but I want you to be able to explain it to me as to why you feel that that is happening, or to explain to me that you understand, that you know that that is happening. So let's take a look at this nice little rainbow arc of the transfer from potential energy to kinetic energy. So this is kind of like marrying everything that we talked about in the last section, where we started making our pendulum, our carnival rides. So this is what it's going to look like. And they're using the example of a golf ball. All right. So right here, it says we're going to have the lowest potential energy right there. And the highest is going to be when it is hit. Obviously, when it is just sitting there, it hasn't had any kind of motion happen at all. That is going to be 100% potential because no motion is taking place. So as it arcs up, let's say we have 10 joules that are going to be in play here, pun intended. It is always going to be that continual 10. It will just be a difference as to whether or not it is potential or kinetic. And remember, potential is not with the motion, but the potential of motion, and kinetic is the actual motion. All right, so continuing all along our nice little rainbow pathway here, right here at the very, very tippity top of it, it says that we're going to have the highest potential energy and the lowest kinetic energy. And then choo, then it goes down and it lands. Let's say we get a hole in one, because that sounds like an amazing day in the neighborhood to me. All right, so then we are going to have the highest kinetic energy when it is actually landing in that cup. Alrighty, So that is everything as far as quote content that is in this section. I feel like it was very straightforward, but if you guys have any questions, definitely let me know. And then from here, you are about to have a quiz on this content. And then the next assignment after this, my fine furry friends, is that we are going to be doing some practice time that goes along with this. So go ye therefore, be awesome, amazing nerds, and I will catch you guys on the flip side. Peace out.